Okay, I think it's yeah. So science and tech, current affairs. Okay. First topic is this Arjuna 2025 PN7. See, we'll see what is this. This is right for now. It is a celestial body in the in our solar system. Now let's understand it. So first thing is, now astronomers have reported Arjuna 2025 PN7, that is Earth's seventh known quasi-satellite, first spotted by this pan stars. He'll understand each term. So this is a celestial body that has been spotted near Earth. Now see, these are the few terms. First term is what you already understand. First is satellite. Okay. For example, natural moons are satellites or natural satellite. Only one natural satellite we have, that is moon. Then this is a natural body that orbits a planet. For example, Earth's moon. After this, you have artificial satellites. These are human made objects placed in orbit around Earth. Example, INSAT, GPS, all this are going around Earth. These are artificial satellites. Now there is something called mini moon. These are temporary natural satellites. So what happens, there are asteroids going around in our solar system. Now sometimes they will come in the vicinity of Earth, and because of the mass of Earth they will start revolving around Earth. That is, they will start behaving like moons or satellites. Okay, so these are mini moons. These are temporary natural satellites, a small asteroid briefly captured by Earth's gravity. It truly orbits Earth for a few months or a year before it escapes again. This is mini moon. Last is this quasi satellite, the example of which is this PN7. Now quasi satellite actually does not orbit Earth, it orbits the sun. It orbits the sun on a path very similar to that of Earth. So this one, the mini moon, revolves around the Earth. Mini satellite does not revolve around the Earth, it follows a very similar path like the Earth when it is going around the sun. Now see its orbit. See this. This is the sun, this is the sun, this is Mercury going around like this, Venus, then you have Earth. This is Earth and this is Earth's path. Very similar to it is the path of this PN7. They have almost, like in 1 year Earth completes the whole round. In almost 1 year this will also complete one round. Now this can be used in many different ways. First of all, it is revolving like this from 50 years, and for a total time period of 128 years it will be at this position, that is almost around Earth all the time, but not revolving around Earth, revolving around sun only. So after 50 years we are able to detect that there is something called this that is revolving around. That is why they have been given names like PN7, Arjuna. So there is no official name as yet. So all these names are being given. Okay. Now
Sir, why can't we call it as a planet? Because it is revolving around this.
no, but it won't have this particular path for all the time. Like after 128 years, it will stop revolving around this path. Earth is revolving in this path for millions and millions of years. Also, there are many more properties to be a planet. Then, now, now, why is some essential facts about this? See, so discovery, this has been found by Pan Stars 1. This is a, in Hawaii they have a telescope by USA. This is observing all of this. Then identify as Earth's seventh quasi satellite. Now you understand what is quasi satellite. Now class Arjuna near Earth asteroid. See, now we also name all these asteroids ourselves. Okay, so India classes all these asteroids by Arjuna class. So that is why they are called Arjuna class asteroids. Now, of course, some other country will be calling it some other name. Now, orbit. Orbit, see, semi-major axis is 1.003 AU. AU is nothing but the unit of measurement between Earth and Sun. So, Earth and Sun is the unit that is approximately the same distance it also has with the Sun. Understood? And revolving around a similar path. Now, next is motion orbits around the Sun, not Earth, remains near Earth due to 1:1 resonance. It means just as Earth is going, similarly it is also going. That is why they are called in resonance, matlab saath saath. Now, duration expected to stay in as a quasi satellite state for 128 years. Okay, after that it will change some path and will stop having the exact path around the Sun like the Earth. Understood? Now, why are they important? See, first thing is they can act as natural lab for understanding resonance, gravitational interactions, all these. Okay, for example, there is gravitational force being applied between Earth and this Arjuna PN7. So that interactions we can study. We can study resonance. Resonance is when they are moving in the same direction in the same way. So how they are forming resonance, all this we can study. Next is some missions like Earth-like parts suits future probes or tech demos. Now, if we have to do some demos, okay, and in the outer universe, what we can do, we can send some satellite or something here. Eventually, of course, we are not in that capability as of now, but because it follows a similar path to that of Earth, this can be used. Like one thing you will study about in space tech is geostationary satellite. What is the main thing about it? They rotate also as the equal to the Earth, around the Earth. Now, similar they are doing around the Sun. So they can be used as a good observatory eventually in future. Right now, after 50 years only, we have been able to identify them. So using them is a far thing as of now. Next, planetary defense. So tracking improves impact, risk, all this, because all these asteroids. So asteroid tracking is an important thing that most of these space organizations do, because any asteroid can collide with Earth and cause destruction here. Okay, so that's why asteroid tracking can also be done. Now, next is this bodyguard satellites. Okay, by the name only you can understand what they'll do. These satellites will go around the more important satellites, okay, and will try to protect them. Okay, now see, so yeah, India is planning bodyguard satellites and a multi-layered defense to protect its growing space assets. Okay, so we have a growing space asset that we have to protect. Now there are many different mechanisms we can use. So one of them that we are going to employ later on is these bodyguard satellites. Now, what are they? These are dedicated escort spacecraft that stay near high value satellites to monitor close approaches, detect threats, and counter hostile proximity maneuvers. It means like our satellite is going, this is a high value satellite, it will be going around it. Now, if some other country in an attack wants to destroy our important satellite, then this will act as a bodyguard, can also provide information regarding all the other satellites. Understood? Then, what are the key threats to satellites? What are the key threats? First is this physical threat, that is high speed space debris impacts. Now, all these satellites, all these rockets, everything that we have sent in space, of course, we have not brought them back, correct? That will cost a lot of money. So, they are all revolving in the space. Now, that is called space debris, matlab space ka kachra. Now, that is going in orbits. Now, that can collide with our satellites and cause harm to them. So, first is this physical threat to satellites. Then, next is digital threat. For example, jamming, spoofing, cyber attacks on space or ground segments. Now, if you know that all these satellites are also being used all are also being tracked by other countries. So they send their radars and try to track our satellites, so that in case of war or just to keep an eye, like USA tracks satellites for most countries. Okay, it keeps on doing this so that it always have an informational edge. Okay, so this also can be a threat that our satellites face. Next is natural. For example, solar storms. Solar storms, so solar, there are a lot of energy that is being released by the sun continuously in form of solar flares and all this, that can also malfunction our satellites. So this is natural threats. Then geopolitical is again shadowing proximity operations by hostile actors. This is what is done in wars, that is to destroy our satellites. For example, you know about ASAT. We have this technology. This is anti-satellite technology, that we can destroy a satellite in space. Okay, now similar things can be done to our satellites also. So that is also a threat. That is a geopolitical threat. Now, okay, how is India protecting its satellites, key layers and technology? Just the names. So one is ISRO's IS for OM. This tracks satellites, debris, issues, collision warnings and all this. Okay, then next is Project Netra. This is ground-based SSA network. It will provide and detect, catalog and threats. Basically, Netra is the new one that we have developed. It is using all kinds of radars and all the systems on ground also, in space also, and collating all that data to provide direct support to our satellites based on navigation, that there may be some debris from here, there may be something from here. So all this navigation is given by Netra. Then you have, of course, Navik, NMA. Navik, Navik is what? India's,
It's like a GPS.
yes, India's GPS. Now it also has a feature. If in the GPS, now GPS can observe a lot of things, correct? Now if it finds something that may be important for the satellite's protection, that information is given. So this is cryptographic navigation message authentications. Okay, then next is Aditya L1. Aditya L1 is a satellite that we are using for solar. Okay, so now one of the threats was what? Because of the solar storms or and all that can be tracked using Aditya L1. Then last is this bodyguard satellites that we understood. Now, these are some international policies. Just the name, not much important. This is UN COPUS. This provides guidelines and global norms for debris mitigation and space operations. Then there is IADC. This is Interagency Debris Coordination and Best Practices. Then there is CSO, Combined Space Operations. This is of 10 nations, similarly providing information to be safe from debris and all others. Understood? Basic. Now, yeah. Now you come to Juno, neutrino detector. See, neutrinos. First thing, I'll try to explain you what is a neutrino. Okay. Now, of course, it is a much more advanced concept. We are still figuring out what is a neutrino and its features, but we'll see what is a neutrino in very short. Okay, very short. Now, don't be bogged down by the equations, not important to you. This is just for your explanation. Now, this is first is beta decay. Now, see how neutrinos came into being. So, there is this boron atom. Now, there was one beta decay. Beta decay is nothing but a release of electrons, you can understand. Now what it became? Now, in this, what happens? Now, this boron has 5 neutrons and 7 neutrons, correct? That is why its mass is 12, correct? So this is 5 protons and 7 neutrons. Now this one neutron has no charge in it. This neutron gets converted into one proton and electron, correct? So this is getting converted into one proton and electron. Now if something like this is happening, now here what will happen? This is getting converted into proton. Now this, out of this 12, 7 were neutrons and 5 were protons. Now one more neutron became proton, correct? So plus 1 here, correct, and 1 gets added here, so this becomes 6. Understood? So that is why it became carbon, and then the same electron is getting released. Now this is beta decay, happens in many different scenarios. Now this whole thing was fine. Now they did the analysis of the energy. Now what they find out is, if you calculate the energy of this and this at the speed that they are moving, they found that some energy is missing. Okay, now like this. Now they find out that this some energy is missing, correct? Now this missing energy was the main mystery that was. Now missing energy meant what? Now they saw that all the charges were satisfied, correct? There you saw charges were completely fine. All the number of proton, neutrons, all were fine, but still some energy was being lost. That is why they understood that there is another particle called neutrino. Now what properties neutrino might have? By this you can understand. First thing, that of course it does not have any charge, because if it has charge, then you would have calculated anyway, either a positive aa, either a negative aa. There should be some charge particle, but there was no such thing, so it will bear no charge. Then if it has a lot of mass or comparable mass, then you would have measured it, you would have gotten it in detectors that some mass is missing. Okay, so that was also not done. So its mass is very small, even smaller than an electron, even smaller than a electron. Then no charge, this. Then another thing is, because it has such a small mass or almost no mass, then it can travel at a speed of almost light. These are the three main properties of neutrinos. First, it has no charge, it has a very small mass, and it is traveling almost at the speed of light. Now if these are the properties, then of course this is very difficult to detect. Okay, right now many neutrinos are going through me, or going through this thumb of mine. Many millions of neutrinos are passing through this thumb right now, but it is not being observed. Okay, why? Because they are even much smaller than an electron, so it does not interact with any part of the cell. So that is why they can pass through your body without causing anything. In fact, they can pass through the entire earth without interacting with any particle. Now because they don't have any charge, they don't have any effect of electromagnetic forces, magnetic field, electric field, all this, nothing. Electrons interact, even though because of that small mass, because they have charge. So they have no charge also, so no interaction with electromagnetic waves also. They have only two kinds of forces that are being applied in them. First is weak nuclear force, and other is of course gravitation, but very small. Why very small? Because it has a very small mass, but it has a mass, so there will be some gravitation and some very weak nuclear force. Okay,
Is it a subatomic particle?
yes, it is a much yeah, subatomic particle. Yeah.
Like a quarks and leptons.
Huh?
Quarks and leptons.
Yeah, some of them, yeah, they can be converted into some of them. Okay, so this is a subatomic particle, very small. So these are the main things, these are the only force that will act on it. Electrostatic force and all those magnetic forces won't act on it. Now you understood this? These are neutrinos. Now let's come to this. Now it is theoretical. See, So China has developed this Juno. Now this is a large neutrino detector built 700-meter underground. It is in focus for answering key questions on neutrino properties. Why it is made underground? Because so that it does not interact with any particles, the very small particles that can interact with it, to be safe from them. Now see, location is Jiangmen, China. Okay, depth understood. Now why underground? Earth's crust shields background particles, especially cosmic rays muons, allowing detection of rare neutrino signals. So now it is already very difficult to detect a neutrino. Now if you take it in the environment that we are living, then you won't be able to detect it. That is why we are taking it underground, so that there is a shield from these particles. Now what are neutrinos? See, so neutral, tiny mass ghost particles, second only to protons in abundance. So they are very abundant in the universe, but of course we cannot feel them. Now why hard to detect? Because they interact only via weak force and gravity, almost never hit an atom, mostly fly through even the entire earth. This we have already understood. Extras, unaffected by magnetic fields, travel nearly at high speeds equivalent to that of speed of light. Then signals are faint and rare, need huge ultra quiet underground detectors to detect them. Understood? Then why do neutrinos study matter? Okay, only thing important here is just knowing all these names. Okay, a few more names we'll see, that of India, of China, so those names you should know. Other thing, why neutrinos matter, and the next thing is basic properties of neutrinos. These are the only three things you need to know. All that, of course, beta decay and all, you know, you need not. Okay, now why do neutrinos study matter? So first is see the unseen, that is reveal the sun's core and exploding stars. Now a lot of neutrinos are coming from the sun. So from neutrinos we can get information about the sun. First is this. Then universe story, help explain how galaxies formed and spread out. See these three things. Now whenever you are learning about any like very different particle from particle physics, this that, if a question comes, these three can always be one of the points. First is understanding the sun, its core and different parts. Second is understanding the origin of universe, and third is understanding what is happening inside the earth. These are the three things कहीं भी आप चेप सकते हैं. Okay, because some way or the other it will help. Okay, so third is of course X-ray of earth, estimate earth's internal heat via neutrinos. So from earth also it is coming above, so you can analyze it. Then nuclear safety. Now monitoring reactors from afar to safeguards. Now nuclear reactions also are releasing, the beta decay is also released in nuclear reactors. So just by observing the neutrinos, see, nuclear reactors have to be closed. Okay, so entire mechanism of their control has to be inside. You cannot let anything escape. But the only particle, or the most abundant particle that is escaping this whole nuclear power plant, is neutrinos. So if you are able to observe these neutrinos, then you can guess that if the number of neutrinos has increased, decreased, based on that we can have analysis. Of course we are not doing much of it right now. We are just first of all trying to detect neutrinos. So this is a probable use. Then useful spin-offs. Okay, this some people, this understanding you need to have, that some people, especially if you are not from science background, you may feel कि ये सब काहे को करते रहते हैं. Okay, so the thing is that most of these things also have spin-off technologies. So because you make detectors like this that can detect such small things, now all these technologies eventually become the technologies that you are using. Okay, most of the thing that became iPhone came from the US Army and NASA. Most things that they had. So everything, it spins off and eventually creates the products that are useful to you. First is done for these extreme cases in particle physics. Then major, just the names. This is Indian Neutrino Observatory. This is right now just proposed. Okay, not operational. Bodhi West Hills, Theni, Tamil Nadu. Then Ice Cube, Antarctica. On this, there was a prelims question about this, mostly about the location. So this is, of course, in Antarctica. Sensors are embedded deep in South Pole. Then you have Trident of China. This is planned tropical one. That one, Jiangmen, that is already established. Juno. Then you have Dune from USA. This is deep underground neutrino experiment, long baseline studies. So these are just the names: Dune, Trident, Ice Cube, INO, and Juno. These are the names you have to remember. Okay, then. Yeah, now you come to Dravya portal. Okay, so Dravya portal is nothing but this Ayurveda portal they have made. All these Ayurveda medicines, prescriptions, they have written in order. Okay, for normal people to use as well as for professionals to use. Now, Ayush launched Dravya. Okay, the full form is just useless. It is like by Ayush vernacular, something they have written. They are just trying to make up Dravya. Okay, the full form is not much useful. They're just trying. They decided that it will be called Dravya, and then they made the full form. Okay, this is a national database of Ayurvedic substances and products. Okay, who operates it? It is launched by Ministry of Ayush, correct? Then operationalized by Kerala Ayurvedic Private Limited. So this company is operating it and it is launched under Ayush. Okay, now yeah, what is it? So this is a searchable reference library. Searchable reference library combining classical text and modern studies for clinical researchers, regulations, industries. So it has combined both the studies. So first is the classical textbooks that you have, Charak Samhita and all. So those are there. Also, there are also a lot of tests that are being conducted on these Ayurvedic practices. Okay, like for haldi, like for some other different components, they have done many scientific studies. Okay, so those both together are being represented here. Then this includes substances, formulations, and products. These are the three things it covers: substances like herbs, metal, whatever is being used; formulations that come from classical books like Charak Samhita; and products, that is proprietary products that they have made. For example, a lot of it comes from Patanjali, that is by Baba Ramdev. Okay, they have different names, like they have one Sitopladi, that is for throat. If you have some issues in throat, then you take it with honey. So all those are proprietary things. Okay, now key features: this is a digital reference. Then it can have advanced filters also. So for professionals, they can apply advanced filters like you do in Mindra and all. You do na कि यही चाहिए, V-neck ही चाहिए, and this ही चाहिए, इतना ही लेंथ चाहिए, half shirt चाहिए, जो भी. So similarly, they can also apply advanced filters. Then yeah, there are two tiers to it. First is this essential and the other is professional. That is, essential is available to everyone for free. Professional is, of course, you have to pay and get that. Okay. Then
So when was this launched?
this was launched recently only. Now they have come up with an app also. I think like last week or two. That's it. Then how does it connect with TKDL? Now TKDL has been a question in mains and prelims also. Now just to not get confused, this is traditional knowledge digital library. So what is the difference between them? So Dravya organizes what we use. For example, substances, formulations, products. That is what we are taking. Okay, that is organized in Dravya. TKDL protects what we know. So TKDL, Traditional Knowledge Digital Library, was made to curb biopiracy. Okay, so what happened? What was happening? That people from other countries were coming to India. They were seeing some different kind of formulations that we take, those nuskhe and all that we use. Correct? This haldi le lo, ye le lo, wo le lo, and then they started patenting these things. Okay, So like they patented haldi and then they started applying different kinds of customs on it. Then India came up with traditional knowledge digital library in which we listed all of it, so that if there is a claim later then we can say कि भाई हमारे में पहले से हम लोग यूज करते आ रहे हैं, this is already in our traditional knowledge digital library. Okay, so that is this. Now here you have formulations, products and all these. TKDL was mostly to protect what we already know, so it was listing what all do we know, and here you have the particular substances and products formulations directly written. Okay, together they strengthen safety, science and sovereignty in Ayurveda in India. Okay, then is this 2G ethanol. Now see this is recently, I think it was covered in environment. There was a bioethanol plant that is established in Assam, correct? Bamboo based bioethanol plant has been established. Now 2G ethanol is in use. See why it is in use. So India has permitted export of 2G ethanol. Okay, subject to of course export licenses and feedstock certificates. Now this is a controversial issue also, that's why you will see op-ed also coming on it, that you are trying to transport 2G ethanol. Now of course all these crops that are being used to make 2G ethanols are water guzzling, that means they require a lot of water, so you are essentially exporting water also. Okay, that is a major issue. Like this ethanol blending with petrol is in use from a long time, correct? All the time there is issues that why this is being mixed, that we started with E20 fuels. Now if everything was to be converted or E20 fuel was to be given to all the vehicles, or we keep on increasing this, then we have to increase the production of ethanol producing crops also. Now out of the 4 main crops that are, 3 of them are water guzzling, so they require a lot of water. So that is a major issue that we may face later on, because you are requiring all this bioethanol, but from where you will get? So from crops like this. Now we have started in different direction, that is we have started exporting this also, so even more pressure on our land and water resources. Now first is these generations of biofuel. First generation came from edible feedstocks, for example sugarcane, corn, wheat. Okay, now what is good about them? Of course this industry has matured a lot, especially sugarcane. Okay, what is bad about them is of course they are using lots of water, also they are using edible crops. Okay, so now instead of growing wheat for people to eat, we will grow wheat to make this feedstock or this ethanol. Okay, so this is a major issue. Now this is mature. Now the issues are food versus fuel and higher land and water use. Then you come to second, which is non-food crops. Now examples of this are using agri residues जो बचता है. Okay, then forestry or wood waste. Okay, municipal waste, all this you will be using to eventually generate bioethanol. Okay, this is second generation using residues, food waste, wood waste, forestry waste, all these wastes are being used to generate bioethanol. Okay, then it may also include not just wheat but crops like bamboo, and there is no, maize is a edible crop. There I don't know the English name. In Hindi it is called Ratanjot. No, there is one more crop that is not eaten by us. Now that is also oil based crop that can also be used to generate this second generation of biofuel. Then third generation will be made by algal biomass. So we will be designing special bioengineered algae that will be very good at producing this biofuel. That is the third generation. Of course The issue is, of course, this has a very high potential because you are growing this specifically for generating biofuel. But the issue is this is too early and still very expensive. Then last is yeah, last is this engineered microbes or advanced pathways. Now last is this bioengineered plants that we'll be making, genetically modified plants that will grow only for production of this biofuel. This is again still at R&D stage. So essentially these two are gone. What you are left with is 1G and 2G as of now, because now the requirement of bioethanol in India is very high. So this is 1G and 2G. Now 1G has many disadvantages, that's why we are focusing on developing 2G ethanol plants. Understood? Then let's see the advantages of 2G versus 1G. So first is no food conflict. Then cut stubble or landfill waste management. Correct? Stubble, like in non-food crops, for example, husk was written. Husk is what? Bhusa. Bhuse ko kya bolte hain? So what is left after cutting the crops that you get now? These crops are there. Now this only is rice. So rice you will cut like this. Then what is left? That is all husk or something like this. Now this can be used. This is stubble. Then next is lower life cycle greenhouse gases, better energy balance, all this. Then less land or water pressure. Then there are many co-products also that can be made using it, like the ones non-food crops we are making. Lignin can be made. Lignin is used in sugar industries. It can back used in making different kind of materials. So all those are byproducts that are being used. Then energy security and rural income. This is fine. Now these are the advantages of 2G over 1G. Then we come to applications. Applications. So first is transport blending. This we have already started, correct? E20 we have reached. Now this can be a pathway to SAF. SAF is what? Sustainable aviation fuel. So eventually we'll get to sustainable aviation fuel, that is we'll be having this in aviation also. Right now mostly we are using different kinds of fuels, from hydrogen to petrol to all these fuels. Then next is industrial feedstock. Now all this can be used to make bioplastics, solvents. Then last is this cleaner heat or power. This is the real use, that is using it as a solid fuel also and liquid fuel. Anyway you are using in petrol. And now we have when there was when there was a lot of backlash that why have we started E20 vehicles, this that, then Gadkari ji came and said that we are starting for diesel also. Okay, so he is
Actually, in the ages we are using the ADF,
in
aviation turbine fuel.
yes, yes,
And the stubble which are we using as a feed to the 2G ethanol, we are
yes,
doing the stubble burning in the north.
yeah. So that stubble can be used here. Yeah.
That stubble, I mean, through the burning we get the 2G ethanol, or
It comes from fermentation. So you take all this feedstock and you ferment it. Using that you get bioethanol. Okay, not burning. Then these are the two initiatives that are in use. There are many initiatives that we'll cover in science and tech lectures. One is this Pradhan Mantri Jeevan Yojana. This is financial support for 2G ethanol products. Then next is this Numaligarh in Assam. They have just now established one bamboo based 2G biorefinery. Correct? So these are the two things that were in use. Then do this. Questions are easy only. When topics are difficult, questions are easy. Easy questions are always asked from difficult topics. So Juno in this about 700-meter underground. Juno's main science is detecting gravitational waves. No, it is for neutrino. Then underground sighting suppresses background cosmic ray muons. Now anyway, if you don't know this also, see this I told you in last lectures also, that if you don't know a term, don't just leave it. In science and tech, some difficult terms are given that you may not be knowing. So focus on something that detail won't be changed. Mostly they change the simple proper nouns. For example, changing this cosmic ray muons. Now instead of this, there are some different particles. You knowing all of this is very difficult for you. They also don't expect you to know. Just the general understanding that they can suppress all kinds of different particles. That's why it is being used underground. That is fine. Based on that only, please mark it. Okay. So this is also correct. What you get 1 and 3. Then next. Done. So it will be simply this ice cube is fine. Then this is being made here. Now dune is not in Japan, it is in USA. That's it. So 1 and 2 becomes the then. One and 3. What is this? Instead of Dravya, it should have been TKDL. TKDL is to protect for patents. Understood? No. So answer becomes what? 1 and 3. 1 and 3. Now let's just see the what you have to remember in all the topics. First topic was what? Arjuna PN7. Correct. First thing, the difference between semi-moon and quasi satellite. What was the difference? Semi-moon is what? Semi-moon is the, yes, it revolves around Earth. Correct. And for only some time. Correct. Then quasi satellite is which is around the sun but following a similar path to that of Earth. Now this is an example of quasi satellite. Okay. Now why are they important? That is just general guessing will work. Then huh? Yeah, to understand different kinds of gravitational. Okay. Then that much for this. Next topic was what? What? Bodyguard satellites. Okay. See, in bodyguard satellites, this you anyway understood. Bodyguard satellite you understood why what it can do. In that we had written in that slide some of the ways in which it can get threats. So that is fine. Other thing that we had written was all the initiatives. Correct. Like there was ISRO's ISO M. Then there was Netra. Correct. Then there was Aditya L1. Correct. Then yes, Navik messaging. So all these you need to remember. Okay, all these different systems that are being used to protect satellites of India. Okay. Then one more that was not written was ASAT. ASAT is also a deterrence mechanism to save your satellites. Because we have ASAT capabilities, no country will try to attack our satellites because we can retaliate. Okay, so ASAT you can also write off. Then after that, next topic was so neutrinos. So neutrinos, what they were? They were very less mass. It had no charge, moving at almost speed of light, and what else? They were affected by only two kinds of forces. Those were weak nuclear force and gravitation. correct? Other things they are not getting affected by. Now neutrinos are being released from everywhere, okay, from inside the earth, from nuclear power plants, from sun. To, if we can detect neutrinos well enough, then we can detect the conditions of sun inside the earth, nuclear reactors. Understood? Now next thing that you need to remember was the names. So there was Juno, there was INO, there was there was there was Trident, and there was Dew. So all these names you have to remember. Okay, then next topic was Dravya. Dravya, see, one thing you need to is Ministry of Ayush. Second thing that you need to remember is that it is, you forget the name of Kerala, whatever, but you remember that it is not being operated by Ministry of Ayush. That's it. Not being operated by Ministry of Ayush. This is important. Knowing the name of Kerala is not important. Then Dravya is a portal. It has formulations, then proprietary compositions and medicines. So all those three products and products, sorry, and products. So these are the three things it is covering in its portal. Of course, all those features that you can always understand in any portal. See, now any portal Indian government makes, na, it will make it multilingual. It will make it for professionals also. It will have some filters also. So all this, if any portal you see and any question you see, you can mark them in general to be correct. Okay. Then Dravya is done. Last was what?
2G.
Yeah. In 2G ethanol, one is that plant that we have established, that is of bamboo in Assam. Okay. Other thing is all the generations of biofuel. So 1G was coming from food crops, 2G is coming from non-food crops, 3G is coming from algal biomass, and 4G is coming from bioengineered, 4G is coming from genetically modified crops. So this 4 generations you need to remember. Now where they can be used, now you are good enough that mixing and all bioethanol, this, that, you understand. That's it. This is all that you need to remember. That's it. Thank you.